Assalamualaikum and greetings everyone. Today's topic is a straight line in the xyz space. Okay, if you recall in high school, if you have a straight line on an xy plane, on the xy plane, let's say that, the formula that you need to use is just y equals mx plus c, where m is the slope of your straight line. But if you have a straight line in a xyz space, you cannot use this formula anymore, but you need to use a vector valued function or a set of parametric equations. Okay, the information that you need to have in order for you to be able to come up with a vector valued function to represent a straight line is you need a point on the line, okay, at least a point on the line, and a vector parallel to the line. Okay, once you have these two, then you can use this formula. So a vector valued function representing a straight line can be obtained through the formula given by, so this is the formula, RT, so it's a vector valued function, equals a vector OA plus T times a vector D. So OA is a vector, well, it is a position vector. This is really a position vector, because OA is a vector that starts from the origin and then it stops at point A. And remember, point A is on the straight line. And vector D is a vector parallel to the line. Okay, so this is the formula, and T here is the a parameter. Okay, so you do need to remember this formula because we're going to use this a lot in the chapter line integral. Okay, now let's proceed to an example. Example A asks us to sketch the straight line RT equals 3 minus Ti plus 3Tj plus 3T minus 4K. And we also need to sketch two position vectors. One is at T equals 0 and the other is at T equals 3. Okay, more room than this. Alright, so here we have the vector valued function RT. Okay, from there we need to sketch two position vectors and also the vector function RT, which happens to be a straight line. Okay, here's a note for you that you do need to remember. If all the components of x, y, and z are all linear, then your vector function is a straight line. Okay, let me repeat that again. If all the components of vector function R are linear, meaning here the x component, the y component, and the z component are linear meaning to the power of 1, t to the power of 1, then your vector value function represents a straight line in x, y, z space. So in this case, the x component is 3 minus t, the y component is 3t minus 4. Sorry, the y component is 3t and the z component is 3t minus 4. Forgot to tilde the sign there. So you do need to use the tilde sign to represent a vector. Okay, I, j, and k are standard unit vectors, so you do need to put the tilde sign underneath them, and r here is a vector. Okay, first let's get the position vector when t is 0 and what's the other one? And t equals 3. Okay. Alright, when t is 0, what we need to do is just replace t with 0 in our vector function. Okay, now the x component would be 3 minus 0, which will be 3. And then we have 3 times 0, which is 0. And 3t minus 4 will become negative 4. Okay, do note here I'm using the notation using the pointy bracket instead of sum of I, j, and k. Alright, and we also need to sketch position vector when t is 3. Okay, now when t is 3, the x component would be 0 because we have 3 minus 3, which is 0. And the y component would be 9, and the z component is going to be 9 minus 4, which is a 5. Okay, or if we're using I and j, and k, that would be 9j plus 5k. And this one would be 3i minus 4k. Alright, okay, let's sketch the first position vector. I'm going to use blue. Okay, remember position vector starts from the origin, so we have 3i, meaning we move 3 units forward, say 1, 2, 3. And then we have minus 4k, so we have to move 4 units downwards. We don't have to move left and right because the y component is 0, so 4 units downwards. So we have 1, 2, 3, 4. Okay, and then you just draw a straight line and then make it a vector. So we have a straight line and then make it a vector. Okay, so that is, so here that's a 3 and that's a 4, 1, 2, 3, negative 4 there, so that is that. Okay, so this is a position vector when t is 0. Okay, now we need another position vector when t is 3. Okay, again we start from the origin, okay, and then we go 0i, meaning we don't have to move forward or backward, and then we have 9j, meaning we move 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a 9. And then we move 5 units up. 1, 2, 3, 4, 5. So that's a 5. And then draw your vector, which is from the origin to this point. Okay, so we have another position vector. This is when t is 3. Okay, remember here, RT is a straight line. Okay, it's a straight line in XYZ space. So for a straight line, you only need 2 points. So what we're going to do now is we're going to connect the endpoints of the 2 position vectors using a straight line, then make it a vector. So your straight line, you just connect the endpoints of the position vector when t is 0 and the endpoints when t is 3, and you can make it a bit longer because it's a straight line. Okay, and make it longer from the bottom as well. Okay. All right, now now you need the direction, because remember RT is a vector, so you do need a direction. It has magnitude and direction. So remember, the direction of your vector valid function is the same way as the direction as t increases. Okay, as t increases. All right, this is where you are on the point, on the straight line when t is 0, and this is where you are on the straight line when t is 3. So obviously the value of t increases from down upwards, so the direction of your vector valid function would be from down upwards. So this is your RT. Okay, so that's vector valid function RT, which is a straight line. So you only need 2 position vectors. You just connect the endpoints of the 2 position vectors using a straight line, and the direction of your vector valid function would be the same way as the direction t increases, the same way as t increases. Okay, so that is example A. How are we doing with time? Okay, C. All right, now I think we can continue with example 2. In example 2, we are asked to find a vector valid function of a straight line which is parallel to the vector d. So this is a vector parallel to the line, and it passes through point 103. So 103 is a point on a vector, on a straight line, which is equivalent to A here. So we're just going to use this formula. All right. Okay. Where am I? Okay, so let's using different orientation here. Okay, now we're gonna move on to example B. Okay, for example B. All right, so we have a vector parallel to the line, which is vector D. I'm using ijk here. I'm using the pointy bracket, so we have 1i plus 2j plus 3k. And we have a point, so I'm going to call this point A, is at, oops, A is at point 103. Okay, So if point A is at 1, 0, 3, then a vector vector OA would be point A minus the origin. Okay, remember, if you have 2 points, you want a vector, you just take the end point minus the starting point. So the end point is at A, the starting point is at the origin where the coordinate is 0, 0, 0. So for vector OA is 1 minus 0, so 1, 0 minus 0, which is 0, and 3 minus 0, which is 3. So OA is really I plus 3K. Right, and then we have the vector. So straight away, we can write down the vector valued function of the straight line. So remember, RT is OA plus the parameter T times the vector parallel to it. Okay, why am I using red? Oh, well. So here we have vector 1, vector OA, which is 1i plus 0j plus 3k. And here we have T times vector D, which is at 1i plus 2j plus 3k. And then we can simplify this. Remember, when you add two vectors, you just add x component with the x component, y with y. So x component now would be 1 plus t. The y component is 0 plus 2t. And the z component is 3 plus 3t. Okay, so that is our vector valued function to represent the straight line that passes through point 103 and parallel to vector D. And of course, you can always write this using I, j, and k. So if you're using I, j, and k, you have 1 plus t I plus 2tj plus 3 minus 3tk. So that's a vector valued function representing the straight line. Or you can write your vector value, your straight line, using a parametric equation. So if you're using parametric equation, set of parametric equation, then you would have x equals 1 plus t, y equals 2t, z equals 3 plus 3t. Okay, so two ways here representing the straight line. You can use a vector valued function using this notation I, j, and k, or you can use pointy bracket there, or you can use set of parametric equations. Alright, that's all. Thank you.